Hey everyone, welcome back to our company-wise DSA series. In today's episode, we are solving a classic Google interview problem. Find the leftmost and rightmost index of a given element in a sorted array. This question tests your understanding of binary search and how you can tweak it to find positions of repeated elements efficiently. Let's understand the problem first. You are given a sorted array and an element x. You have to return the first and the last index of the element. If the element doesn't exist, return -1 -1. For example, v equal to 135555 67 123 125. X equal to 5. Then the output 25. That's because 5 first appears at index 2 and last appears at index 5. We need to solve it in big O log n time, so we will use binary search. Normally, binary search finds one occurrence of an element, but here we need both the first and the last occurrence. So, we will modify binary search slightly. For the first occurrence, when we find x, we don't stop immediately. Instead, we move left to see if there is another x before it. For the last occurrence, same logic, but this time we move right to see if there is another x after it. This ensures we find the extreme left and the extreme right indices of that number. First, we define a function indexes that takes the vector and the target x and returns a pair of indices. Then we store the size of the array in n. First and last are initialized to -1. If x is not found, we will just return these defaults. Then low and high set the range for binary search. Now we run the loop while low is less than or equal to high and calculate mid in the way that avoids overflow. Now we run the loop while low less than or equal to high and calculate mid in a way that avoids overflow. If vmid equals x, we have found an occurrence. But since we are looking for the first one, we move high to mid -1 to keep searching for the left side. If vmid is smaller, the target is on the right side. If larger, move left. The standard binary search adjustments. After we finish the first search, we reset our low and high pointers to run binary search again, this time for the last occurrence. This second loop is almost identical, but notice the difference. When b mid equal to x, we move low equal to mid plus 1 to go right and find the last occurrence. Every time we find x, we record last equal to mid. Once the loop ends, first and the last contain the required indices. Finally, we return both the indices as a pair. If the element wasn't found, both remain -1. Both the searches are big O log n each. So the total time complexity is big O log n and the space complexity is big O 1. And that's it. We have successfully found the first and the last occurrence of an element in a sorted array using a simple binary search trick. This pattern is extremely useful in interview questions, so make sure you practice it well. If you found this explanation helpful, don't forget to like, subscribe and turn on the bell icon for more company-wise DSA tutorials. In the next episode, we will solve another question from Google's interview list. See you there.